All right, welcome back. In today's lecture video, we're going to look at the base catalyzed aldol reaction. Now, this is in our chapter of reactions at alpha carbons of carbonyl compounds. And up to this point, we've had alkyl halides and halogens like Br2 or maybe just Br2 as an electrophile. Well, today we're going to start looking at carbonyl compounds as electrophiles in these type of reactions, and in particular in the aldol reaction or the aldol condensation, we will have aldehydes and or ketones as the electrophile. And I'm going to start with a simple example. We'll look at the mechanism of the base catalyzed aldol reaction, and then I'll try to give one more example after that. So in this simple example, I'm going to take acetaldehyde. So this is an aldehyde, and I'm going to react it with itself. So another molecule of acetaldehyde. Okay. And the base catalyzed conditions, what we typically show for that would be sodium hydroxide and water. All right. And what's going to happen is we're going to form a bond between that alpha carbon. Oops. I want this to be green. There was a reason I used two colors. Okay. Between that. Okay, so we're forming this CC bond. Okay. So between the alpha carbon of one of our reactants and the carbonyl carbon here of the other reactant. And so this would be our new CC bond. Okay. Organic chemists have a special place in their heart for carbon-carbon bonds because this is how we make bigger molecules, okay, and sometimes you need bigger molecules. It's not just enough to play around with functional group interconversions every day. Eventually, you have to make something. So, anywho, let's look at a mechanism for this reaction. All right. So remember, this is a base catalyzed reaction. So we want to be, when we're drawing our intermediates, we want to be watching and make sure we don't have too many plus charges floating around, okay? Because that's going to be a sign that we're doing something wrong. All right, remember sodium's just a spectator. So we're going to use the hydroxide here. And we are going to do a very familiar step, which is a proton transfer. And that makes this ion okay. This is our enolate ion. We saw this in a previous lecture. And then this can then react with another molecule of the acetaldehyde. And maybe should I try to squeeze it in here? That's probably a bad idea. Okay. And we've got some lone pairs on this oxygen. We like to keep track of our electrons in mechanisms. All right, because we're moving electrons around. All right, next step. We've got a nucleophile. We have an electrophile. We're going to do this. And what do we call this? I can't hear you. There you go. That's right. It's a nucleophilic addition. All right. And don't worry, all those people in the listening audience that said SN2, I didn't hear it. So no need to be embarrassed. All right. How am I doing? Not so good. Did you see what I just did? My goodness. I wish I could say I did that on purpose, but I didn't. I dropped a carbon. I may need to get more sleep. All right. How am I doing now? All right, so we got one more step to get to the product. All right. What do you think that's called? That is a proton transfer. And I may not have enough room to do this, so I'm going to squeeze it in here. Okay. And one thing I forgot to mention, these really should all be equilibrium arrows, okay? Because this reaction, the products are not much more stable than the reactants, or they might even be less stable in cases. I think with the aldehydes are roughly as stable as the products, or the reactants and products are roughly similar in stability. All right. Whew. Well, I went to all that work to add this second color here, and now I'm just not using it. Okay. All right, so in summary here, our base catalyzed aldol addition has a proton transfer followed by a nucleophilic addition followed by another proton transfer. Now, can anybody guess why it's called an aldol reaction? All right, here's the answer. We have an aldehyde here. That's the al part, and we have the ALD part, okay, and we have an alcohol here. That's the ol part, okay. So we have a carbonyl, alpha, beta. We have a beta hydroxy carbonyl compound. We could also do this with ketones, okay, but it's a little less to draw if you just start with an aldehyde. Okay, great. So let me give you another example of the base catalyzed aldol reaction. All right, and this one I'm going to do a little more in line notation. I'm going to do a bigger molecule. But not too big. I got to conserve my space here. Let's see. How many carbons do we want? We'll do an aldehyde, and we'll do 5 carbons. 1, 2, 3, 4, 5. Okay, and we're going to do 2 of that same molecule. Oops. Now, I know some of you, well, maybe not, maybe you're not particularly, maybe you don't care, but some of you may want to use a different aldehyde. Okay, probably not, but let's just say you do. And I will get to that later. That's called a crossed aldol. Later being a different video. Okay, so what's the product going to be of this reaction? Well, to figure that out, I want to identify the alpha carbon on one molecule and the carbonyl carbon on another molecule. Okay, and we're going to form the CC bond between those two. Okay, so the way I like to do this is put one of them here, and then I'll kind of flip the other one over like this. Make sure I haven't lost any carbons. Okay, that would be a no-no. Don't lose carbons. 1, 2, 3, 4, 5. Okay, here's the new CC bond right here. We had a hydrogen here. OH. Okay. Let me put some numbers here so you can kind of see this. 1, 2, 3, 4, 5. And we'll call this 9, 6, 7, 8, 14. Okay. the key thing we want to notice here is we're making a bond between 2 and 9. Okay, 2, 3, 4, 5. And then here's 9, 6, 7, 8, 14. It doesn't matter what these numbers are, you just need to recognize that we're making a bond between the correct numbers. Okay? And you can also see here's the alpha carbon, this would be a beta carbon, so we have a beta hydroxy aldehyde that we're making. All right, so that's going to conclude our video lecture on the base catalyzed aldol reaction. In my next lecture, I'm going to cover the acid catalyzed aldol reaction, which is going to make the same type of products, but the mechanism is going to be a little different. Thanks for watching.